Very good morning to one and all. Today, actually, we in the previous classes we were there in your module number 3. This is the syllabus of your module 3. So, where Sir has discussed about 8085 microprocessor, then its key features, then the corresponding architecture, pin diagram, right? Then what we have seen the different addressing modes, then instruction set, right? So then one more thing, 8085 interrupts also we have seen in the previous class. In that instruction set, there are totally 5 types. Out of that, 3 were completed in the previous class, and the remaining 2, he will continue in this afternoon class. Okay. Today we are completely moving to some other the second part of your module 2. Am I audible, sir? Okay, fine. We are complete. Sir, can you mute the audio? Okay. So we are completely moving to the next part of this our module 2 or 3, that is unit 5, where we are going to see the performing interfacing. Okay, interfacing, how we are going to interface different devices or different microprocessor, or we have so many purposes using the microprocessor, right? So we are going to how we are going to interface these things with the other devices. That's what we are going to see in the second half of your module number 3, that is unit 5. So in that there you have to study about 3 devices. First one is programmable peripheral interface 8255, then programmable keyboard and display interface 8279, and the last one is programmable interrupt control 8259. Okay, so we are going to study about all these 3 devices today. And one more thing, most important is you have to remember the name 82. In most of the question papers, you may get architecture of 8255. It is not necessary to be asked about a programmable peripheral interface. It can be asked about 8255 directly as it is, right? So you have to remember the name. 8255 is programmable peripheral interface. 8279 is programmable keyboard and display interface, and 8259 is programmable interrupt controller. So you have to remember about these 3 numbers. Okay, so you must by heart these numbers, and if you are getting a question like define the architecture or draw the pin diagram of 8259, so that time in your mind it should become like that 8259 is programmable interrupt controller. This is what we are going to study today. Programmable peripheral interface, you can call it as a PPI, programmable keyboard and display interface, and the last one is programmable interrupt controller, PIC. Okay, this is what we are going to see today, and we will start with the 8255 programmable peripheral interface. So 8255, the purpose of 8255.
Excuse me, madam. Can you make it full screen? Can you make it full screen?
Yeah, okay.
Right, sure.
Is that okay?
Yes, madam. Yes.
Okay, sir. Okay, so 8255 is a programmable peripheral interface, or you can call it as a PPI. Okay, so PPI, what is the use of this 8255 is you need to transfer the data from to and from the microprocessor. You need to receive the data as well as you need to transfer the data. That is the purpose of 8255 programmable peripheral interface. Okay, so mainly it has a input output device. Okay, it is an input output device, which means that you have to transfer the data as well as you have to receive the data from the outside devices to the microprocessor. So you are using an 8255 as an interfacing unit to connect between microprocessor as well as some other devices to transfer and receive the data. Okay, so this is 8255. This is a general purpose programmable input output device which is designed to transfer the data from input output to interrupt input output under certain conditions as required. Okay, so and another point is it can be used of any microprocessor. So there are different microprocessors are there. 8085 is one, 8086 is another one, then 8051 microcontroller is there. Okay, so there are different types of microprocessors are there, and 8255 is compatible with all type of the microprocessor. Next one is, so mainly this is to transfer and receive the data. Okay, so what is the main requirement? It has to be a port. Okay, then how many ports will be there? There are actually 3 ports will be there. Okay, there are 3 ports will be there, and each port is a 8-bit. It is 8-bit. 8-bit and bidirectional. Bidirectional means it can send, also it can receive the data. That is the meaning of a bidirectional input output port. So this is a 3 8-bit port. So how many pins will be there? Totally 8 into 3, 24 pins will be there, or 24 input output lines will be there for the 8255 programmable peripheral interface. Okay, you understood? So 8255, it is nothing but to transfer as well as receive the data from the outside devices. That is the main purpose. And another thing is it is compatible with all type of microprocessor. And the third point is it is a it has totally 3 input output ports will be there, and it is bidirectional. Bidirectional means you can transfer as well as receive your data. That is the meaning of a bidirectional port. Then these are the features of 8255. Okay, so it consists of a 3 8-bit input output ports that we have seen in the previous slide. So 3 8-bit ports, so to 3 into 8, totally 24 pins will be allotted only for the input output ports. Okay, totally 24 pins will be allotted for the input output ports. So 3 ports are, you can name it as PA is nothing but port A, PB is port B, and PC is nothing but port C. Okay, there are 3 ports. It is named as port A, port B, and port C, that we will see later. Then address and data bus must be externally demuxed, because then only it can transfer and receive data from the multiple devices. Then this is a TTL compatible logic, and it has improved DC driving capability. So these are the features of the 8255. Suppose if you have a question like in 2-mark question, what is the features of 8255? You have to mention all these points. Main thing is the port must be there. Okay, so this is only for transfer and receive the data. So you must focus on the port. So totally 3 ports will be there. They are port A, port B, and port C. Now we are going to see the ports of 8255. So 8255, we have seen that there are 3 ports. They are port A, port B, and port C. Right. So each one is 8-bit port only, but the difference is port A, port B, it both are act as an 8-bit port. Right. It will both act as an 8-bit port, but port C, it will be act as a 2 4-bit port. Okay, port A and B act as an 8-bit port. It is a complete 8-bit port. Okay, you can transfer 8-bit at the same time. But in the case of port C, it will be act as a 2 port. So one is 4-bit and the second one is 4-bit. So that is known as port C, that is split into 2, that is port C lower and port C upper. Lower means PC0 to PC3, that is lower. There are totally 8 pins will be there, right? So that you can name it as PC0, PC1, 2, 3, 4, 5, 6, 7. So these are the pin numbers. And so the PC0 to PC3, which will be considered as your lower port, and upper part of this port C is PC4 to PC7. So these are 4-bit and this is 4-bit. Okay. So port C, which is a it is divided into 2. Each one is having 4 bits. Okay, each one is having 4 bit. So port C is a 2 4-bit input output port, but port A and port B are same as nothing but 8-bit port. Okay, then what is saying about the port A? So it is an 8-bit output latch buffer and one 8-bit input buffer. So latch means output is latched. Somewhere you are going to see the name of latch. What do you mean by latch? Latch means once the output is received in this corresponding register, the output is not going to change whenever you are changing the input. That is the meaning of latch. Okay, so whenever you are require another output, that time only it is going to change. So if you are changing the input, it is not going to change the output which is available in the register. That is the meaning of latch, that we will see later also. So that time you should remember what you mean by latch. Then again it is the ports are divided into 2 groups. First group is, you can call it as a group A, and the second one is, you can call it as a group B. Okay, so the group A, which consists of port A and upper port of C. Okay, similarly group B, it is named as port B and lower port C. Okay, so the complete port, you have seen that port A, B, C. This is again divided into 2 groups, group A and group B. So port A and port C upper, and in group B, port B and port C lower. This is the way it is grouped into 2, group A and group B. Now, next thing is, I think you are clear with what are the different ports which is available in 8255. Right? Now what we are going to do is, we are going to see the modes of operation, right? In this modes of operation, this is nothing but a control word. This is nothing but a control word. The operating modes, basically it is classified into 2. First one is bit set or reset mode, BSR mode, bit set or reset mode, and the second one is input output mode. So this input output mode is further divided into 3, that is mode 0, mode 1 and mode 2, that we will see later. So first what we are going to see, what is the meaning of a bit set or reset word. So this is nothing but the control register. This is nothing but the control register. This is an 8-bit register. In this control register, whenever D7, this bit, last bit, MSB bit, right? D7 is nothing but your MSB bit. So whenever your MSB bit D7 is equal to 0, this 82555 will be acted only in the bit set or reset mode. Okay, so D7 must be 0 for making sure that it has to be work in the bit set or reset mode. Similarly, in the input output mode, the D7 bit, if it is 1, it will be work in the input output mode. Okay. So if D7 is equal to 0, D7 is equal to 0, this 8255 will be work in the bit set or reset mode. When D7 is equal to 1, it will be work in the input output mode, right? Then D6, D5, D4, it doesn't have any meaning. So it can be, don't care, you don't bother about that. Then what is going to the bit set or reset word is, it will be set or reset the port C bit. It will set or reset the port C bit. So this is an 8-bit. This is an 8-bit port. Port C is an 8-bit port. So PC0 to PC7 will be there. So you can put it as a 0, 0, 0, 0. If it is D3 0, D2 0, D1 0. If this is 0, 0, 0, what will be happen? You will get to your that is equivalent to PC0, right? Then 0, 0, 1 is equivalent to PC1. Then 0, 0, 1, 0 is equivalent to PC2. So similar way, you are going to vary these numbers here. So which bit you need to set or reset, that number you have to substitute here, D3, D2, D1. And in case of D0, if it is 0, this corresponding pin. The corresponding pin will be reset. If it is 1, the corresponding pin will be set as 1. That is the meaning of bit set or reset mode. So D3, it is based on D3, D2 and D1. So D3, whatever, which, suppose if you want to set or reset the PC5. So PC5, 5 means what is that? It will be equal to 101, right? It is equal to 101. So 101, you are substituting 1 in D3, D2 as 0, D1 as 101. So then if you want to set, means you have to substitute D0 as 1. If you want to reset the PC5, you have to substitute it as a 0. Right, this is what is a bit set or reset mode. So only thing is you have to draw the control word also while they are asking about the modes of operation, right? You have to draw. If it is an essay question, you must draw the control word also. Control word is D7 is equal to 0, D6, D6, D5, D4 can be any values. It is don't care, you are not bothering about that. Then D3, D2, D1, D0. D3, D2, D1, which is nothing but the port C bit number, and D0 set or reset the corresponding port bit. Okay, port C bit. So if it is 0, it is reset, and if it is 1, it is set. Now we are going to see the input output mode. So here what you are going to see here, it is in the input output mode of operation, you are substituting D7 is equal to 1, it will be in the input and output mode, right? So then here D6 and D5, it will be mode of selection for port A. Okay, it is a mode of selection for port A. So if it is 0 0, mode 0, 0 1, mode 1, 1 0 or 1x 1, this one will be 1, and D5 will be, it can be any 0 or 1, it will be in the mode 2. So port A will be working in the 3 modes of operation. They are M0, M1 and M2. Then what about the D4 bit? D4 bit will select the input or output function of port A. So okay, first 3 bits is used for the port A. So input output function of port A, if it is 1, this is act as an input mode, and if it is 0, it will be act as an output mode. So that is the input output function of the port A. Now we are going to see that is D3. D3, so port A plus group, first we are going to see the group A. So port A plus port C upper. So input output function of port C upper is given in D3. That is also, if it is 1, it is his input function. If it is 0, this is output function. Then D2 will choose the mode of selection of the port B. So if it is 0, mode 0. If it is 1, mode 1. So it can be if it is 0, mode 0. If it is 1, this is in the mode 1 condition. So port B will work only in the 2 modes of operation, that is mode 0 and mode 1. And the D1 bit will select whether it is input function or output function. And it is port C lower is along with your port B. So D0 bit will select the input output function of the port C lower. I think you can copy down. Once you're done, you please let me know. I hope you understood how to write the control word for the input output mode of operation. If any doubt, please let me know. No doubts? Everything clear? If yes or no, please post, and then only we came to know that whether you understood or not.
There is a response from C section saying it is clear.
Oh, okay.
A, B, A, B, A. Okay, fine, good. No doubt, madam. Clear, madam. Okay.
Oh, okay. Now you copy down the control word. Okay. Once you complete it, please let me know, because that control word is bit important for you. Okay. So if in the question paper, if it is an essay question, you must draw the control word, or else you can ask write the control word of BSR mode of operation in the 2-mark question itself. You may get right. Shall we proceed? Okay.
Yes.
Now, this is actually here what we have seen about. We are seeing different modes in the input-output mode of operation. They are mode 0, mode 1, and mode 2, right? So now we are going to see what is mode 0, mode 1, and mode 2. So in the mode 0 operation, port A and B, which is used as two 8-bit ports, and port C, it will be act as a two 4-bit ports, what we have seen in the starting. Okay, so we were discussing about this in the starting of the what are the ports, which are the ports available in the 8255, right? So in the mode 0 operation, port A and B will be act as a two 8-bit port, and port C will be act as a two 4-bit port. Okay, so totally how many ports will be available for the input output mode of operation? There are totally four port will be available, right? First one is port A, second one is port B, third one is port C upper, and fourth one is port C lower. So there are totally 4 ports will be available for the mode 0 of operation, and each can be programmed as either in the input output of mode. It can be either in input mode of operation or in the output mode of operation. So whatever things you require, you can write the control word. It is not a problem. You know how to write the control word. Then it is outputs are latched and inputs are not latched. So latched meaning also we have seen. So once the register is completely filled with the data, if you are changing the input signals, the output is not going to change. That is the meaning of latched condition. So output is latched. So it is not a fluctuating one. So once you store the data, it will be there. Okay, that is the meaning of the latched. And input is changing. It is not latched. So whatever input comes, the input is going to change. That is the meaning of not latched. And it doesn't have the interrupt capability. Once it is received, when the microprocessor it accepts, then only it will send the data. Okay, it doesn't have to interrupt the processor. So that is the mode 0 operation. So here what you have to see, the main focus is which are the ports is used in the mode 0 of operation. So in this case, port A and B used as a two 8-bit ports, and port C as two 4-bit ports. That is mode 0. Then next one is mode 1 of operation, where port A and B used as an 8-bit input output port, but in the case of port C, each port, okay, port A will be used 3 lines of port C as the handshake signal. Port A will be used 3 lines as handshake signal. Similarly, port B used 3 lines of port C as a handshake signal. So port A uses either from, it is from the port C upper. It is from PC4 to PC7. It will be used for PC4 to PC7. Any of the 3 lines as a handshake signal. And in the case of port B, it will be used port C lower, that is PC0 to PC3. Any 3 signals as the handshake signal. That is in the mode 1 case. And here input and outputs are last. That is a mode 1 condition. And next one is mode 2. So in the first, in the control word itself, you have seen that mode 2, port A only work in the mode 2. Port B and port C are not working in the mode 2 of operation. So port A can be configured in the bidirectional port, but port B, it will be act as a mode C, mode 0 or mode 1. Okay, only port A will be act in the mode 2. At the same time, port B, it can be act in any mode 0 or mode 1 of operation. And also port A uses 5 port C signals. Port A uses 5 port C signal as the handshake signal. So other remaining 3, remaining 3 will be there, right? Port C, remaining 3 will be there. So if port B is used in mode 1, the 3 will be act as a handshake signal for the port B. If port B will be act as in mode 0, what will be happen? This remaining 3 as an input output signal itself. That is a mode 2 of operation. You understood? Is that clear? So there are 3 modes: mode 0, mode 1 and mode 2. So in the mode 0 of operation, port A, B as well as port C as the input output port. That is a mode 0 of operation. Then what happened to mode 1? Mode 1, port A and B will act as the input output port, and 3 bits of port C will be act as the handshake signal for port A, and the 3 bits of port C will be act as the handshake signal for the port B. That is a mode 1 of operation. Then in the case of mode 2, in the mode 2, only port A can be work in the mode 2 of operation. So what will be happen to port B and port C? Port B will be act as either in mode 0 or mode 1. If it is work in mode 1, 5 signals from the port C also will be given to port A as a handshake signal, and the remaining 3, if port B is in mode 1, remaining 3 will be act as the handshake signal for port B. If it is in mode 0, port B doesn't have any handshake signal. So that time it will be act as a normal simple input output mode of operation. It will be the port C also will be in the mode 0 of operation. It simply transfer the input output data. I hope it's clear, the 3 modes of operation: mode 0, mode 1 and mode 2. Is that okay? Shall we move to the pin diagram?
Yes, madam. We'll proceed.
Okay, sir. So this is the pin diagram of 82555. So this is a 40 pin IC. So you are starting from 1 here, 20 up to 1 to 20, then 21 to 40. Okay. So usually one dip will be there. Okay, while it is a small dip will be here for an IC. So from there only you can start the pin number 1. Right, from there, from the lower side, you can start the pin number 1, and it will be named from 1, 2, 3, 4 up to 20, then 21 to 40. This is a 40 pin IC. Here, we know that there are totally 3 ports, right? 3 ports will be there. So those 3 ports, it is an 8-bit port. Each one is 8-bit port. So totally 24 pins will be there. So here 1 to 4. Here PA0 is starting from here. PA0, PA1, PA2, PA3, and the remaining PA is here. PA5, PA5. This is 4, 5, 6, and 7. So these 8 pins carries your port A pins, PA0 to PA3, here PA4 to PA7, right? Next one is PB. Here it is PB0, 1, 2, 3, 4, 5, 6, 7. So next 8 will be taking care of the PB0, port B bit. Then the last one is port C. Here 14th pin is PC0, PC1, PC2, PC3. Then 13th pin is PC4, 5, 6, 7. Okay, these are the ports. PC port, C port. So A port is over, B port is over, C port is over. Then 27 to 34, it carries the D0 to D7. That is nothing but the data. Data has to be, it has to receive the data, no? So that data has to be sent or received. Once the data has to be sent to the other devices, or the received data has to be sent back to the your microprocessor. That is D0 to D7. Then another pins, supply pins will be there. That is VCC, 26th pin, VCC is your supply pin, and also 7th pin ground is your supply pin. One is positive potential, one is in the negative potential or in the zero potential. So depending upon whether it is plus or minus 5, or it is 0 to 5 volt. So based on that, you have to put the VCC and ground. So VCC, here you are connecting plus 5 potential, and the ground you are connecting 0 potential. If it is minus VCC, you are connecting minus 5 volt. This is your supply pins, VCC and ground. Then this one is chip select. So chip select, usually this is a in the negative potentials, chip select bar usually. So if it is 0, that time only this A2555 will be active. Chip select means nothing but at that time only your A2555 pin will be, the IC will be active. So it must be in the 0 potential. If it is CS bar, it must be in the 0 potential. If it is CS, it must be in the potential 1. Either your potential 1 means nothing but you are giving plus 5 volt. Otherwise, it must be 0 potential. So then only your 8255 IC will be worked. Then read RD bar and WR bar. This is read command, and this one is write command. Read means the device will read, device, the microprocessor will read whatever things will be available in the 8255. Similarly, WR bar means the microprocessor will write the content into the other devices. That is write command. So that is read and write. Then A0, A1, that is another thing. You are going to select, it is a read, write, input, output. All these functions will be based on A0 and A1. So that one table will be available that we will see. Reset is you are going to reset your pin. Reset your IC. Again, resetting from you are starting your IC. That is resetting. Right, it is no need to give switch on and off. You can directly give a potential to the reset pin. Then it means that you are resetting your 8255 IC. That is reset. So I hope all the pins which are available in the 8255, it's clear. I hope so. We will see all those things in detail in the next slides. Now, this is the architecture of 8255. You take a bit of time and you can draw the pin diagram. Once you draw it, you please let me know. Did you finish? Did you finish the drawing?
I think we can proceed, madam, with architecture.
Okay. Now next is the architecture part, 8255 architecture. So architecture, the main thing is you have to remember both pin diagram as well as architecture. So compared to pin diagram, architecture is more important, but we cannot tell that pin diagram won't ask, right? So it can be asked anything. So you must be familiar with both the pin diagram as well as architecture. If the pin diagram is drawing, you have to explain all the pins which are available in this pin diagram. So from 0 to pin number 40. So first you can write it like 1 to 4, then as well as 37 to 40, that is port A. Like that you have to explain all the pins which are available in this pin diagram. Similarly, in the architecture case, you have to draw the architecture diagram as well as you have to explain about each and every uh, uh, blocks which are available in the architecture diagram. Okay, so these are this is the architecture of 82555, where we have two power supplies plus 5 volt and ground. Then we have seen that you have a group A control and group B control. There are two groups, right? So group A means port A plus port C upper, and group B is port B plus port C lower. This is nothing but group A control as well as group B control. Then there is read or write control logic, which is common to all the ports, right? Which is common to all the ports. Then data bus buffer. So data has to be received or sent from these devices. Then RD bar, WR bar, A1, A0, reset, CS bar. So all these things we have seen in the pin diagram itself. We will see each and every block in detail, right? And this is an 8-bit internal data bus. So if arrow is in both direction, means this is a bidirectional. So data can be transferred from here as well as data can be received from here. That is the meaning of in this arrow in this both directions. Here also this is bidirectional. But here you see group A control, then this is for group B control. A control, which is separate control, is given to group A separately and port C upper separately. It is not together, right? So this is an internal data bus. This is only receive the data from. You cannot transfer the data to the internal data bus. It is only receive the data from. Receive the data only. And here also group B control. But in this each and every port, it is a bidirectional. Okay, all these things are bidirectional. And then port A, it is PA0 to PA7 input output, that is bidirectional. Then port C upper, PC4 to PC7, that is bidirectional. Then port C lower, PC0 to PC3, that is bidirectional. Then port B, PB0 to PB7, that is also bidirectional, right? I think you draw the diagram, then we will go for the further explanations.
madam. Can you make it full screen?
Okay, sir. 1 second. I hope we can continue. So we will see the each and every block in detail. So first one is data bus buffer. Okay. So data bus buffer, the data is transmitted and received by the buffer and as per the instruction of the CPU. That is the important thing of the buffer. Okay. So there you are using D0 to D7, and in the pin diagram also you have seen that D0 to D7 pins are there. So this D0 to D7 pins as per the instruction from the CPU or the processor, it will receive or transfer the data to the outside devices, and also not only data. Sir, hello.
Yes, madam.
No, somewhere it is unmuted. That's why I am asking. Any issues?
No. You proceed. Let me check.
Okay, okay. So this data bus buffer, it is transfer as well as receive the data as per the instruction of the central processing unit or the processor. Okay, and it is an 8-bit buffer that you know that you have D0 to D7 pins are there. So that is an 8-bit buffer only to interface the microprocessor to the system data bus. And also not only data, it is also transfer and receive the control words and status information, which is also transferred using this bus. Okay, you can transfer both the control words, status information as well as data using this data bus buffer. Next one is read or write control logic. So read or write control logic here, where it is. So it is responsible for controlling the internal as well as external transfer of data, control and status word, right? So that you have seen here, this is read or write control logic. Read function will be there, write functions will be there, right? So read and write. Read means microprocessor will read the information which is available in this data bus buffer or in the data bus or in the port everywhere. Okay, it will read the information. Write means microprocessor will write the informations to the other devices, which is peripheral devices which is connected with the processor. That is the meaning of read or write command. Then so it can data, control and status word, whatever it can be, it is reading the status word or control word, similarly data, as well as it is writing also. So and also other thing is it is input from CPU address and control buses, and all these control informations will be, everything will be done using the read or write control logic. Then CS is nothing but the chip select. That also we have seen that chip select, it is usually chip select bar. Okay, so chip select bar means whenever it is 0, if it is 0, then only your device will be active. Suppose if you are giving a +5 volt here, it won't be, your device will not be work. That is the main device. It is chip IC will not be work if it is CS is equal to 1. If CS is equal to 0, then only your IC is going to work. Then you are going to decode the address using A0 and A1. So here you see, suppose chip select must be 0, that you know chip select must be 0. If it is 1, your device will not be work. That is the meaning. So A1 A0, if it is 0 0, port A will be selected, 0 1 port B will be selected. If it is 1 0, port C will be selected, and if it is 1 1, the control register will be selected. That is the use of this A1 and A0 pin. So 0 0 means you are not giving, it is in the ground potential. 0 0 means it is in the ground potential, then port A will be selected. 0 1 means you are giving +5 volt to this A0 pin, then port B is working. And if it is 1 0, you are giving +5 volt to A1 pin, then port C is working. And if it both are in the +5 volt A1 A0, the control register will be working. That is the meaning of this A0 and A1. WR, you know, that is it stands for write operations. When the signal goes low, the microprocessor writes into a selected input output port or the control register. That is the meaning. So because this is a WR bar. Similarly, RD bar, this is a read operation. So microprocessor will read the instructions which is or the data which is available in the data pin or in the control register. It will read or write. Reset means this is active high. It clears the control register and sets all port in the input mode. That is the meaning of reset pin. Now this is nothing but A0, A1, read, write, chip select logic. Chip select is always 0 because CS bar you are using. Similarly, RD bar and WR bar is using, right? Sorry, here it is WR like that it is considering. So 0 0 means port A. 0 1 means it is a write operation. So port A is writing. So port A to database. It is given data from port A to database. If it is 0 1, this is port B. 1 is writing, right? 1 0 means port C. Port C is writing, right? Then now it is a read operation. Sorry, right? So read operation. So if it is 0 0, data bus, whatever data will be there, it is reading by the processor, right? This is to port A. 0 1, that is data bus to 0 0 and 0 1, this is for this is port B. Okay, this is port B. And 1 0 2 1 0 1 is port C, and 1 1 it is port D. This is not port D, that is nothing but the control word. Okay, this is nothing but the control word. This is what is A0 and A1 operation. A1 signals which is available there in your 8255 A0 and A1, which will select which port it has to be selected. Based on this, it is based on this which port it has to be selected. A0, A1. So 0 0 port A, 0 1 port B, 1 0 port C, 1 1 is control word. Read and write command is, it is reading and writing. If it is read is enabled, it means it is reading the commands which is available in the ports as well as the registers, right? That is read command. WR means the CPU will write whatever things, the control word, status word, whatever it is required, it is given to the device. That is the read and write command. So this is about the 82555. So 8255, what we have seen in the first one, we have mainly it is based on, it is a port, input output port for that function only it is using. So that is the first case you have to see. So there are 3 ports will be there. They are port A, port B and port C. Port C will be act as a 2 port, that is port C upper as well as port C lower. So there are totally 3 ports will be there. Then the modes of operation we have seen. The basic mode of operation is BSR mode and input output mode. BSR mode is nothing but when your D7 input is 1, BSR mode is 1. Sorry, input is 0, your BSR mode. If it is 1, D7 is 1, it is in the input output mode. Then also input output mode, again it is what to say, input output mode is again classified into 3, that is mode 0, 1, 2, right? Mode 0 means A, B, C, both, all the 3 will be act as an input output port. In mode 1, A and B will be in the input output port, but port C will provide the handshake signal to port A and B. Then mode 2, only port A will be in the mode 2, and port B will be, it will be in mode 0 or mode 1. Then 5 signals from port C will be act as a handshake signal for the port A, and the remaining 3 either as a handshake signal to port B, or it will be in the simple input output mode. This is the modes of operation we have seen. Then what we have seen in the class, we have seen about the pin diagram. It is a 40 pin IC. We have seen all the pin number pins. Then architecture diagram also you have seen. This is the architecture diagram, and there is 2 control, group A control as well as group B control. I hope it's clear.
When you draw the architecture, you just have to keep in mind the number of blocks which is available inside. Okay, primary concern of the evaluation part will be the number of blocks. Here in 8255, we mainly look at whether you have splitted this port C into port C upper and port C lower. Understand the other half of the block architecture. You will find port A and port B which is complete, and port C is splitted into 2. Right? And the same thing on the right side, you will find 2 other modes which are available, right? So group A and group B. Okay. So first part is we will count the number of blocks. Second is port C, whether it has been splitted as lower and upper. And then we will see whether there is 2 groups which are available, group A and group B. And of course, the remaining is very simple, a data bus buffer and a read-write control logic. Okay. So this is one of the architectures which is very easy for you to understand and draw. Okay. Though it might look a bit complex or something, it is very easy. 4 blocks, 2 groups, a data buffer, and a read-write controller. Okay. Hope it's clear. Can Madam proceed to the next peripheral? Just drop a message in the chat box so that there is no clarification. You can go ahead with the next control, the next architecture for the other peripheral. Can we proceed to the next one? Yes, no, maybe. Nice. Yes, we can. Okay. Taken for granted. Yeah. Okay, madam, we should proceed to the next peripheral.
Do you have any deadline submission today? Any deadline for submission? Any lab or something? No, the thing is why they are not responding. That's why I'm asking.
No, there are a few responses which is starting to come, so no problem. We can proceed to the next architecture.
Okay. Now we are moving to 8259. So once it is completed, we will move to 8279. Okay. So 8259 is a bit easy compared to your 8279 for understanding. So that's why we are going with the 8259. That is programmable interrupt controller. Okay. Programmable interrupt controller 8259. 8259, also you can call it as a PIC microprocessor, PIC microprocessor, that is programmable interrupt controller. So what is the requirement of this programmable interrupt controller is, usually in 8085 and 8086, you have a very few numbers of interrupts, hardware, I'm not speaking about the software interrupts. You have only few hardware interrupts are available, right? So 8085, you have 5 hardware interrupts, and 8086 only 2 hardware interrupts are available. So suppose if you want to add more number of peripheral devices, definitely all the peripheral devices will be working through the interrupt routine only, right? So it is require a more number of peripheral devices. If you connect a more number of peripheral devices, the similar way it has to be, so more number of interrupt handling capacity must be there, right? So we are adding this 8259 to increase the interrupt handling capacity. We are adding this 8259. That is the main requirement of the 8259. So 8259, we can increase the interrupt handling capacity. So a single 8259 will provide 8 interrupts. It is provide 8 interrupts, and also you can cascade it. If you are using 2 8259, you can 8 plus 8, totally 16 devices you can be handled. Again, 3, if you are 3 8259 you are using, you can handle 24 interrupts like that. Okay, so you can cascade this 8259 connection. That is also one biggest advantage of this interrupt controller, right? So here you can multi-interrupt input source to a single interrupt output. So it is provide 8 interrupts from IR0 to IR7. Okay, so 8259 is nothing but an interrupt controller. So it is enhance the ability of controlling the interrupts of the microprocessor. So you can add more number of interrupts, or you can add more number of peripheral devices to the same CPU or the system. That's why we are using 8259. That is a programmable interrupt controller, PIC microcontroller, PIC controller, right? So this is designed only for 8085 and 8086. 8051 it is normally not using. 8085 and 8086 only, microprocessor alone. It can be programmed either in edge triggered and level triggered mode of operation. Edge trigger, you know what you mean by edge trigger. Edge means once edge 0 to 1 transition or 1 to 0 transition comes, it will be considered as an input. Level trigger means it has to be constant for a 0 level, it has to be constant for a 1 level. That is nothing but the level triggered mode of operation. And of another advantage is it can mask the individual bits of interrupt request register. Mask means it can mask data. Okay, it is not necessary to be always given. You can mask the data of input devices. Then another thing we have also see that 8259 we can increase the interrupts up to 64. So totally 8 maximum you can 8 8259 chips you can cascade it together. Then you can increase the interrupt handling capability up to 64, and it doesn't require any clock cycle for the synchronizing the operation. It will be automatically synced. It doesn't require any clock cycle. So these are the main features of the 8059. Now we are going to see the pin diagram of the 8259. We are going to see the pin diagram of 8259. Then next one is functional diagram. Then we are moving to the block diagram of the 8259. Right. So here this is a 28 pin IC. 8255, that was a 40 pin IC. Your 8085 is also a 40 pin IC, but 8259 is a 28 pin IC. So ground and VCC are nothing but your power supply pins. Then CS bar is chip selector. WR bar and RD bar are nothing but your read and write commands are there. Then IR0 to IR7 is nothing but these are your interrupts. Okay, interrupts which is your this 8255 having these are the input. So here you are connecting the peripheral devices. IR7 you are connecting one peripheral, IR6 you are connecting another peripheral, IR5 you are connecting another peripheral. These are the peripheral devices. INTA is nothing but interrupt acknowledgement signal. Okay, once it is receiving the interrupt, it is acknowledged that we have received the interrupt signal. INT is nothing but interrupt. It is checking for the interrupt whether it is coming or not. SP bar and enable is nothing but enable the devices. CAS2, CAS0, S1. This is used for cascading the cascading the 8255 devices. Okay, you can up to maximum 8 devices you can cascade it. So only 3 control signals are required. So because 8 is maximum 3, this is 3 bit only, right? 8 is maximum 111, right? 0 to 7. 0 to 7 means 111. So it is require only 3 bit CAS0, CAS1 and S2. It is used for cascading the multiple 8259 ICs. Then what is next? D0 to D7. This is nothing but your data inputs. Data. This is a bidirectional. You can receive the data as well as you can transfer the data. This is bidirectional. All these pins are unidirectional only. Okay, all these pins are unidirectional only. CAS0, S1, S2 is bidirectional, and this enable signal that is also bidirectional. And here you see INT is coming out of this 8255. INTA is coming inside to the 8059. So not 8255, 8059. Okay. So this is the pin diagram of the 8059. Now this is the functional diagram. Functional diagram is same only, but it is comprising like IVCC ground as your nothing but your power supply pins. D0 to D7 is your data inputs, data pins. Then CS bar chip selector, WR bar, write read command, A0, INT, INTA. These are the interrupt acknowledgement. This is enabled command. IR0 to IR7, these are nothing but your interrupts which are available. CAS0, SA1 and SA2, this is nothing but your cascaded pin input. So only thing is you need to remember about this pin level diagram. Then all the pin details will be available here. Okay, all the pin details will be available here. So you can only thing is you have to remember this pin level diagram. You have to draw the pin diagram where you have to mark the pin number from 1 to 28. See here, one dip is here, right? So this is your starting point. You cannot start from here, you cannot count from here 1. So wherever you have a dip in the IC, from there you have to start it as 1. Okay, 1 2 3 4 up to 40, then 15 up to 28. This way you have to count the pin number, right? This is the pin level diagram. Now we are going to see the block diagram of the ICs. Okay, first you draw the pin diagram, then we'll move to the architecture. You draw the pin diagram and please let me know once it is completed, then we'll move to the architecture. Okay, we'll move to the block diagram. So once it is completed, I will give time to draw the both pin diagram as well as your architecture diagram. Okay, so this is a block diagram. Block diagram, data bus buffer is there. So all these points will be same as your normal A255. Okay, this is data bus buffer was there in A255. Read or write control logic was there. Then control logic. So these are the additional things. Okay, these are the additional things, and this is where there. So data bus buffer as well as read or write control logic will be available for all the peripheral device controller. Okay, these two blocks will be available for all the peripheral devices. Okay, data bus buffer, read or write control logic. Then cascaded buffer, CAS0, S1, S2. It is connected, cascaded buffer or comparator. Then this is data bus, control logic, interrupt request register, priority resolver, in-service register, and interrupt mask register. So these 4 points, or including this one, control logic, these are the main features of the 8059 processor. Okay, 8059 PPI. So PIC, 8059 and PIC. These are the main points. So here you might have get a question in TOMARK itself, what is interrupt request register, what is IPR, then what is priority resolver, what is in-service register, what is interrupt mask register. So you may get question in TOMARK also regarding this. Explain what is interrupt mask register, or in the essay type question also in you might have get explain all the following. Explained, then part A, this is IMR, part B ISR, part C IRR. It's a 2 mark, so totally 6 mark. So these kind of questions you can expect from the architecture of the 8059. So you have to study thoroughly what is meant by all these blocks. So I think we don't need to spend time for the data bus buffer. This is same as what we have seen in the 82555 also. The same explanation you can write it for data bus buffer here in the 8059 as well as 8259 as well as 8279. So wherever it is required, you can write this data bus buffer. So everything is having the same commands. Okay. This is nothing but to transfer as well as receive the data. That is the only meaning of data bus buffer. But here what is happening is it transfers the opcode of the selected interrupts and address of ISR to the other connected microprocessor. So what you mean by opcode, mnemonics, all those things will be explained by Shiva sir in the afternoon session. So that time you will be clear about what is mean by opcode and mnemonics, how to write the program, all those things will be clear, right? So I don't need to go in detail with the opcode here. So in the 8259, the opcode is nothing but the address where it is located. So that so each and every command, it has a particular opcode. So you in the previous classes you have seen that move A comma B, move A comma 0, hash 0H, like that you have seen, right? So it has a particular value. It has you have a data sheet, and in that you can see the what is the meaning of opcode, operational code, right? So this opcode of the selected interrupt. So every interrupt has a corresponding opcode will be there. So that is the address of ISR to the other connected microprocessor. That is a function of data bus buffer. Then read or write control logic. So chip select will be in 0 point. Data depending upon the inputs RT and WR, that also you know what you mean by read and write, R bar W. Read and write will be in the logic 0 condition. So you might be knowing, you will be know what is the meaning of read and write command. Now, the most important thing here is control logic. So control logic, it has 2 pins. First one is INTA and the second one is INT. INTA means interrupt acknowledge signal, and INT is interrupt pin. That is interrupt pin. INTA is interrupt acknowledgement. Okay. So what is the INT pin is actually the 8259 which is connected to either other microprocessor for taking the interrupt request. So the IND pin is used to give this corresponding output, right? So the 8259 will receive the interrupt signal, that is the IND signal will be used. So suppose that your microprocessor is accepting this interrupt and it is letting know the 8259 that I have accepted the interrupt which is given by you. Okay, that is the interrupt acknowledgement. I have to acknowledge that I have received the signal. That is the meaning of acknowledgement. So INTA is acknowledgement signal which is given by the microprocessor, and INT is nothing but the interrupt which is connected to the other peripheral devices. So if 8259 is enabled, the interrupts flags of either microprocessors are high, then this causes the value of the output INT pin as high. So in this way, this chip can respond requests made by other microprocessors also. So this is nothing but for controlling with the other microprocessors. So once it is received the interrupt signal, it is connected to the microprocessors. INT is given that I am sending the interrupt to you, and INTA is acknowledging that I have received I have received and I am processing the interrupt signal which is sent by you. That is an acknowledgement signal. Okay, that is nothing but the control logic. Now next is interrupt request register. Here you are going to see three registers. First one is interrupt request register, interrupt service register, and the last one is interrupt mask register. Request register is actually many peripheral devices will be there, right? So all the peripheral devices is asking for communicate with your processor. Okay, that is nothing but an interrupt. So all the processor which is which need to be communicate with the processor, microprocessor, it is sending a data, right? It has some control word or something like that. So that request is received in the interrupt request register. So all the processes are communicating with the interrupt request register. So whatever communication comes into the 8259, that data is received in the interrupt request register. Then interrupt service register means your processor is working out with a particular interrupt. Okay, it cannot work with the multiple interrupts. It will work one interrupt at a time. So what interrupt it is working, that particular data will be stored in the interrupt service register. That is the interrupt service register. Then interrupt mask register means sometimes you need to based on the prior, it is no need to given the data or the interrupt to the microprocessor. That is decided by the based on the priority. It is decided by the your 8259 itself, right? Okay, pick itself. So that is used for the mask register. So it stores interrupt level that will be masked by storing the masking bit of the interrupt level. So these are interrupt request register, interrupt service register, and interrupt mask register. Now the priority resolver. Priority resolver means what to say? In the priority resolver, what it has to do is it will set it. Your 8259 will be receiving multiple interrupts, right? It has to receive 8 interrupts at a time. So then it will check which interrupt has the highest priority. So that will give the highest priority to the ISR, okay, IRR, in interrupt service register. That request is given to the ISR, right? In the interrupt with the highest priority, which is given to the ISR, and others are it can be masked, or whether it is checking whether it is already executed or not. That also it will be checked, and reset the interrupt level which is already being serviced in the IRR. This is what is priority resolver. It will check which interrupt is received, which interrupt has the highest priority that is received by the 8259 pick. So the highest priority will give first to the ISR, then next highest priority, then next, then last is the least priority. It is given to the ISR register. This is the priority register. Then cascaded buffer, as you know that this is nothing but it is used for cascading your 8259 ICs. So there are 3 pins will be there. So if you need to, you can cascade at maximum 8 8259 ICs, that is cascaded buffer. This is what is your 8259 programmable interrupt controller. Okay, so this interrupt request register, so there are 8 pins are connected, right? So it can receive 8 inputs, sorry, 8 interrupts from different peripheral devices, and those data, those values will be stored in this register, and this data is given to the priority resolver. So priority resolver will prioritize which has the highest priority, okay, which has the highest priority, and that is sent to the in-service or in-service or interrupt service register. It is given to the interrupt service register, where interrupt service register holds the value which is being currently executed. That is a interrupt service register. Mask register means something which is not required, something I don't want to compute or process the particular interrupt. So that particular interrupt you can mask using the interrupt mask register. Then control logic is nothing but INT is, which is you are sending, you are receiving the data from here, no? So you are executing one particular interrupt in this register, and which you are sending to the through the control logic to the other processors, right? So it is given to the particular processor, and from that processor you are receiving an acknowledgement that I have received the data which you have given. That is the control logic. This is what is the block diagram of the 8259 programmable interrupt controller. If you have any doubt, please let me know, or else you can draw the block diagram. Is that clear? Architecture of 8259 is clear?
Now there are answers which says they are clear with, right? Since they are busy with copying down the block diagram, maybe that's one of the reasons that they are not responding. Good.
In diagram.
Can you just go to the pin diagram slide? Yeah. Sudarshan, pin diagram for 8255 or 8259. On screen is for 8259. Pick. Yeah. Thank you. On screen. Madam, can you please make it full screen? Yeah. Thank you. I suppose with this topic we can just come to the end of this class, and the third peripheral I suppose we can see in the next class. I suppose, is that okay, madam? Because it's already 10:58.
Yes, sir, sure.
Yeah.
We'll continue the same thing in next Saturday session. Today
Yeah.
you may continue that
Yeah.
that topic.
After we'll see simple programs. No problem. So I hope you can summarize the complete today's class and we'll end the session, madam.
Yeah, sure, sir. Okay. So what we have seen today, 8255 as well as 8259. Okay. So 8255 is nothing but input output ports. It is mainly speaking about the ports. Three ports will be there. Then how to control the ports. Then how to transfer the data. How to receive the data through the ports. That's what we have seen in the 8255. Then the second one we have seen about 8259. That is nothing but a programmable interrupt controller. So what is the use of this programmable interrupt controller is you can connect a multiple more number of peripheral devices, because usually in this 8085 and 8086 are having very few numbers of the hardware interrupts pins will be available. So we are connecting 8259 to receive to give more number of interrupt services to the microprocessor. That is the main advantage of is the main agenda of this programmable interrupt controller. Then what we have seen here is it is as a pin diagram as well as a block diagram we have seen. Then data bus buffer and control logic. So all these things are similar to your normal 82555 only. So additional thing is cascaded buffer is there. So it is you can cascade more number of 8259 units. Then control logic is there for getting interrupt as well as acknowledgement. It is receiving acknowledgement signal as well as giving the interrupt to the processors. That is control logic. Then interrupt request register is there. Priority resolver is there. In interrupt service register is there, and the interrupt mask registers are there. So IRR will receive the interrupts. Priority resolver will prioritize which has the highest priority. Then in service register it will execute the current whatever be needed to be executed. In service register will hold the value. Then mask register, some of the interrupts need not to be executed, so that you are making it as masked. So this is nothing but the block diagram of 8259. In the next class, we will see about 8279 programmable keyboard. Okay, that we will see in the next class. This is what is about our today's class. I hope you understood. If you have any doubts, this is very, very easy to study. Only thing is you need to remember the pin diagram as well as architecture, because almost all the explanations will be same. You can score very good marks from module 3. It is not so difficult as your module number 2. Okay, so this is basic theory only. It is easy for you to score marks in module 3. Module 3. I think this is up to today's class. Stop recording.